Welcome to our tutorial video of how to port PyTorch models to Cerebras systems. Regardless of the framework, we always need to identify 4 different steps in our code: the setup, the data, the model, and the execution. This helps us to divide between what happens off the chip and what happens on the chip. In the case of PyTorch, we use CBTorch. That is a Python module that provides a custom implementation to adapt PyTorch code to Cerebras systems. We imported it using cerebras.framework.torch as CBTorch. This module helps us to do training and validation of our CA systems, and it supports pre-compilation and execution. For today, we are going to use the code provided in our docs.cerebras.net. In our documentation, you will find a section called Porting PyTorch Model to CS. In this section, there are 2 different snippets of code. One that uses CBTorch, simple.py, and another one that shows the code without CBTorch. In simple.py, you will find that the first instruction that we use is to import CBTorch as cerebras.framework.torch as CBTorch. Now let's go through our 4 different steps and let's see how CBTorch grabs different functions of PyTorch. The first step is to initialize cbtorch.initialize. This function helps us to define what is the IP of our CS system. In the code, you will find that the first function that is called is main, that you find it at the end of the code. And indeed, the first instruction that you will encounter is cbtorch.initialize. In here, we have specified the IP of the CS system, and if you want to compile the code, you will add an additional flag called compile only. The second step is to load the data using CBTorch data loader. This is a wrapper of torch.utils.data.dataloader. Again, what happens inside the data loader is happening outside of the CS system. In our example code, you will see that we are using train data loader as the wrapper for a function called getTrainDataLoader. This function creates a data loader inside it that takes samples of MNIST and returns them to be able to train the model. The third step is to grab all of the NN modules using CBTorch module. Remember that when we use a torch.nn.module is where we define the architecture of our neural network. And in the case of the CS system, these layers are the ones that are mapped on the chip and are trained on the chip. In the code, you will find that we have a function called MNIST, that is a class that inherits from module, and it has the forward definition of our layer. At the same time, in main, we use cbtorch.module to grab MNIST and define the model that we are going to train. The last part of our pipeline is to define the execution. We can either compile our code to check if it is compatible with our CS system and to generate the executables to run on our CS system, or directly launch training and validation on the CS system. In either case, we are going to use cbtorch.compile for compilation and cbtorch.session for training and evaluation. This code is implemented to run training on FCMNIST. That's the reason why we have a run function that uses cbtorch.session. It defines what is the data loader that we are going to use for training, and then it defines the mode equals to train to specify the execution mode for the code. Like that, we have learned 5 different functions that are used from PyTorch to grab different functions on Torch. All of this information and more you can find in our documentation at docs.cerebras.net. Next, we are going to talk about how the PyTorch is used in our Cerebras reference implementations. Thank you.